This series of videos looks at applications of vectors, not including area and volume. So first of all, vector and Cartesian equations of a plane in 3 dimensions. You need to remember that normal vectors to planes. So for any smooth surface, at each point on the surface, there is a line perpendicular to it. So you can see that in regards to this red line in the diagram. So for a plane, these perpendiculars are all in the same direction. A vector that is perpendicular to the plane is called a normal to the plane, which we've already covered before. Now, there is not a unique normal vector for a given plane. If the vector n is normal to the plane, then so are the vectors kn and negative kn. Okay, for all k element of the reals. Now, equations of planes, the equation of a plane written in Cartesian form is expressed as ax plus by plus cz plus d equals 0. To calculate the equation of the plane, 2 important features are required. We need a point pxy that exists on the plane. So you can see that in our diagram. A vector that is perpendicular to the plane, that is the normal, which you have there. So consider the diagram shown. The locations of points P and P0 can be defined by the position vectors. P, X, Y, Z equals R times by P0, A, B, C, which has to equal our vector A. So the vector connecting the points can be defined as P0P, so that's this line here. And that's going to equal R minus A. So start at the starting point of what we want and end where it ends. So that's minus A and R. As we are asserting that R take A lies on the plane, it will always be perpendicular to the normal. So what we mean by that, R minus A is lying on the plane, and that plane is perpendicular to our normal. We can rewrite that as R minus A dot n has to equal 0 because the dot product of perpendicular vectors is 0. And that's because cos 90 degrees equals 0. So from that, we have the vector equation of a plane being R minus A dot n equals 0, or R dot n has to equal A dot n. So what we're doing there is we're expanding our brackets. So R dot n minus A dot n equals 0. So that leads to R dot n has to equal A dot n. The Cartesian equation on the plane as well, ax plus by plus cz plus d equals 0. Now check your formula sheet and see what is on it that's going to help you with this.